Section 1.3, trigonometric functions on real numbers. Now, in this lecture, we will define the trigonometric values of any angle in standard position, and we will find the reference angle, and we will use the reference angle to find the trigonometric values of any angle. Now, we extend the trigonometric values from the right triangle to all angles. So here this is the acute angle, alpha acute. But after some time we will try, okay, cosine 50 degrees and sine 30 degrees. It's all coming from the right triangle. But after some time we will try to get what is cosine 100 or sine 200 degrees. So these trigonometric values have some applications in real life and technology. So we want to know how, from the right triangle, how do we take this one and extend it to all real numbers? So, and if we have like sine 1000, can we do it? Okay, trigonometric values of an angle between 0 and 360. Here, to do such thing, we will place the angle in standard position. The first thing is, okay, if you take a value like, for example, 200, how will you do it? How will you find the cosine or sine? Or, okay, here's a question. Let's say, well, how can you find this one? Or how can you find this one? Now, first, place the angle in standard position. Take a point on the terminal side of the angle. And this is what we do exactly in the previous lesson. In the previous lecture, we learned if we have a point here on the terminal side of an angle, so we take this x and y point, and then we say this cosine theta is x over square root of x squared plus y squared, and here sine theta is equal to y over x squared plus y squared. We can take its square root, and then we write the tangent also. We do exactly the same thing. Here our angle might be in the second quadrant, or our angle might go up to the third quadrant, or it might end at the fourth quadrant. At each of them, like, we take a point on the terminal side, we find the xy value here, and then directly we write cosine theta in terms of x and y, and we take y over square root of x squared plus y as sine theta. We know the formula, so we will use exactly the same formulas as in the first quadrant. Now, my suggestion is, if you don't remember the rules, okay, you can always use the formulas in the first quadrant. So if you don't remember the rules here for the for cosine theta, what is this? Is it this one or is it the other one? So how can you make sure? I recommend you go and draw as if it is like theta is like in the first quadrant, and then use these x here and y here and write the formulas this way. But when applying x or y here, x might be negative or positive, so depending on the quadrant here. But the formulas are coming from the first quadrant. You can use the first quadrant to derive the formulas. To get the formulas, then you can substitute x and y. They might be negative or positive depending on the depending on the quadrant. Okay, I'm talking about these formulas here. So we can use this formulas to get the value, the trigonometric values of any angle. So theta can be here, and this xy can be here, or theta can be here, and we might have a point here, xy. And we will use all these formulas to find the trigonometric values for any for any angle here. It might be an obtuse angle, it might be an acute angle, it might be this type of angle here, between 180 and 270 degrees. So you take any xy point on the terminal side, or you can take the fourth quadrant here. Sorry, this is not theta, this will be theta, sorry. So this is xy. You can use the formulas here. And one other thing is we can have theta as 0 degrees or 180 degrees or 90 degrees. So for example, what about this? If theta is 90 degrees, what happens? Or if it is 180 degrees? So when you take, this is the terminal side, then when you take any point here, it will be something like, okay, let's say minus 5, 0. So x will be minus 5, and then y will be 0. And when you try to get the tangent value here, the tangent 180, it will be something like 0 over minus 5, which is 0. And in the same way, if you try to do this cotangent 180, it will be minus 5 over 0, which is undefined here. So here the warning says this one, says this fact, the terminal side of a quadrantal angle. So quadrantal means like the terminal side is in on the x-axis or y-axis, so 0 and 90 degree, or 180 or 270 or 360. So if we have this type angle here, then x or y will become 0, and it will make some of the trigonometric values undefined. So because if x is 0, then secant theta is undefined. If y is 0, then cosecant theta is undefined. Now we'll see them in the examples. Now, for example, find sine 135 degrees by choosing a point on its terminal side. Let's do the first part here in the example. So let's put this 135 in the coordinate system. So this is the terminal side. It's 135 is like you go 90 degrees here up to here, and then 35 more. So it will get you here. So it will be 35 here. So it's 45 degrees and 90. So it's 45 degrees this part and 90 degrees this part. So it will be in total it's 135 degrees. So 135 degrees. Now we want to choose a point here. Okay, I'll make this one longer. So I take a point here and look at this point. They give me a point on this line. So what line is it? It's 45 degrees here also. So it's the 45, 45, they complete each other. They're complementary angles. And if it is 45 degree angle, degree triangle, so these should be same, these distances. So when you take here minus 2, you can take minus 2 here. You have to take 2 here, right? So it will be minus 2, 2. A point is minus 2, 2 here, so you can calculate sine 135 degree as what is it? This is, okay, I don't remember it, so I will try to remember it from here. But it was x and y, so I would say this is x, this is y. This is square root of x squared plus y squared, and this is sine theta is what? Muqabil, or opposite side, divided by the hypotenuse. So y divided by square root of x squared plus y squared, right? Now, to remember this, I'm using the first quadrant to remember the formulas. But when applying it, so I apply the actual values of y and x. So it's minus, it will be 2 divided by minus 2 squared plus 2 squared, and then it will get 2 over square root of 8, which is 2 over 2 squared 2, and this will give you 1 over square root 2. Or if you rationalize the denominator, you got square root 2 over 2. Like you multiply square root 2 both sides, and you get this one. Okay, this is how we do it. Or if you want, you can take minus 1, minus 1. You can also take minus 1, minus 1. This is another point. Or you can make big values like minus 5, 5. It will give you the same thing. But the idea here is to just pick a point and then use the formulas for the trigonometric values. Find cotangent and cosine of the angle theta whose terminal side passes through minus 1, minus 2. So again, first let's place the angle. The angle is minus 1. It's passing through minus 1, minus 2. So it's minus 1, minus 2. It's here. So we are talking about an angle whose terminal side is in the third quadrant. So this is the terminal side here. So terminal side is this one. So this point here on the line is minus 1, minus 2, and theta is this, and we want to find cosine theta. What's the formula for it? Okay, now I will do it. I mean, I'm taking the formula from the first quadrant. So this is x, this is y, this is square root of x plus square root of y. So theta, it's mujawir, the adjacent side divided by the hypotenuse, it will be x over x squared plus y squared. And then, okay, this is just to remember, okay, to this this formula. Now we apply x and y from the actual terminal side, or the point, actual point on the terminal side of theta, which is minus 2, minus 1, minus 2. So it will be minus 1 divided by minus 1 squared plus minus 2 squared. Take the square root, so it will be minus 1 over square root 5. We can do the same thing here for cotangent. So it says find the cotangent here. Okay, from here, what's the cotangent theta formula? Cotangent theta is 1 over tangent theta, or y over x is tangent theta, so x over y will be cotangent theta. The adjacent side divided by the opposite side is cotangent theta. Now I'm taking the actual values and put here, so it will be minus 1 over minus 2, which is 1 over 2. Now here is the solution. In the solution here it says it's with the help of the protractor. So since you know 45 degrees property, so you don't have to use a protractor here. You just, you form the triangle and then you take a point such that it's same distance here, same distance here. And the other one is easy to see. Now let's keep doing this for different angles. Here tangent 90, find tangent 90 by choosing a point on its terminal side if defined. Okay, 90 degrees. Okay, let's try to put this 90 degrees here. Okay, 90 degrees is this one here. So this is the initial side, and for the 90 degrees, this y-axis will be the terminal side. Terminal side of 90 degrees. Now let's take a point on this terminal side. Okay, it is just a point on the y-axis. So of course you will not choose the origin. So let's take, for example, the easiest one, I guess, is always 0, 1. So x is 0, y is 1. And what is the tangent formula? Or for 90, okay, tangent 90. So remember the formula. What's the formula for this? I don't remember it, so I will go to theta here. So I will make the right triangle on the first quadrant. The y-x, this is square root of x squared plus y squared. So tangent theta, opposite side divided by the adjacent side, so which is y over x. So I will write here y over x. Okay, what is y here? This is x is this and y is this, and then I will put them here. So it will give you 1 over 0, which is undefined. So what we get here is tangent 90 degrees is undefined. Now in the same way, let's try to find 180 degrees. So tangent 180 degrees by choosing a point on its terminal side. So here is the initial side, and then where is 180 degrees? 180 degrees is here. It makes 180 degrees. So the terminal side here, is 180 degrees. So it will be, okay, 180 degrees. The terminal side of is on the x-axis, but on the negative part. Let's take a point here. Okay, take any point. It can be anything, like, okay, I will choose -2, 0. Okay, then I will use the same formula for tangent here. What's the formula for tangent? Okay, tangent formula is tangent 180 is now y over x. What is y? This is x and this is y, and then I put this x and y here. Y over x, so y is 0, and this is -2, and which is 0. So what we get here is tangent 180 degrees is equal to 0. Now, this is an easy way of finding the tangent and all the other trigonometric values of the quadrantal angle. So the angles at 0 angle or 180 or 90 degree and a 270. Without using a calculator, you can do this and you can find them. Okay, let's repeat the same things for different angles. Now please stop the video and try to do it by yourself, and then I will do it, and then you can compare your solution with mine. Okay, let's start with A. Find the trigonometric values of 350 degrees by choosing a point on its terminal side. So what is 315? It's 90 here. This one is 180, and then this one is 270. And the whole thing is 360, but we need 315. So it has to be somewhere here, I guess. Yeah, somewhere here. So it's better we choose this angle here. You know, if you want to choose this point here, we need to have some information about this right triangle here. Okay, what is this? 360 minus 315 makes, okay, this whole thing is now 315, okay, regardless of these. And we end up with 45 degrees. So if you make a 45 degree triangle, I mean 45 degree here, so you will see that they will be same. The distance, these distances will be same. But when you take a point here, then Okay, take the point, so the x will be positive here, let's say 1, but y value, okay, it's 1 here, but it will correspond to -1 on the y-axis, right? So because this is the fourth quadrant, so I will use this triangle formula. Says cosine theta sine 315 is equal to, now it's x over square root of x squared plus y squared. This will be 1 over square root 2. And then you will end up with sine 315, and which is y over square root of x squared plus y squared. And you can use this numbers here for x and y, and you'll get -1 over square root 2. And then tangent 315 is equal to y over x, and which is equal to -1. You will see here. Yeah, you can do the rest like by taking the reciprocals of them. You can find the other values. Another one is, it says find all trigonometric values of the angle theta whose terminal side passes through 1 and -2. This is all about, you know, using the formulas. Here 1 -2, 1 x is 1 and y is -2. 1 is here, -2 is here. So it will be an angle in the fourth quadrant, so like that. Now, how can you find the cosine theta here? Okay, if you don't remember the rule, you can use this one here, x, y squared of x squared plus y squared, and use this rule. It's cosine theta is mujawir, the adjacent side divided by the hypotenuse. And then use here 1 and -2 for x and y, and then you'll get 1 over square root 5. And sine theta is equal to y over x squared plus y squared. And you can write this rule from here, and then put the x and y values here. So it will be -2 over square root 5. And then tangent theta is same again. Tangent theta is like y over x, and then you put these values and you will get -1 over 2, -2 over 1, which is -2. And you can do the rest by taking the reciprocal. Now, when it comes to this question, again, the secant 180 degrees. Okay, let's look at here. 180 degrees is this. Okay, now what's the terminal side? Terminal side is this one. Take a point. Okay, I will do -1, 0. And how do we find secant theta? Secant theta is 1 over cosine theta. And if you write the formula for cosine theta, you will end up with, okay, what? Again, x or theta, xy squared of x squared plus y squared. So it will be 1 over x over squared of x squared plus y squared. And then when you do this one, it will be squared of x squared plus y squared over x. Now you take this x and y and then use substitute them here, and secant 180 will be equal to, okay, don't tell it's theta now, because theta was for the formula, for the general formula. And now secant 180 is square root -1 squared plus 0. It will be 1 here divided by, okay, we put them in the formula, and x will be here -1, so you will end up with -1. So we take these two values and put it here, and we get these two values. Okay, in the same way, you can calculate these values by using 45 degree, the property of the 45 degrees. So the good thing about 45 degrees is here, if you have something like A you will end up with like a. So you can take 1, 1 here, or if you have 135 degrees, you can take here 1, but here you can get -1. This time you get 1 minus 1. Sorry, this is -1, 1. And if you take 215, so it will be something like, okay, that's the, you can make, it doesn't look nice, my drawing here. So like 255 is something like this here. It's 45 degree again. This whole thing is on 225. And this thing is like 45 degrees, so you can make this triangle here again. But here, these are same distance, but here it will be a negative value. You can say it's -1. You can choose this y component to be -1, and then this component to be -1. Then you can end up with -1, -1, and then use the formula for cosine, and then sine, and use them here, x over square root, you know, this, and you get -1 over square root 2, and you can do the rest by using this x and y formula. So I will not try to do it one by one, but I can quickly, you know, fill out this, I guess. So it will be 1 over square root 2, 1 over square root 2, and this is 1, and this is the, you flip the tangent, sorry, this will be 1, this will be square root 2, and the cosine theta in 135, it will be something like here 1 over square root 2, this is -1 over square root 2, this is -1, this is -1, and okay, you can do the rest, but the important thing here, we want you to focus here these values. These values are same as you see here, same, but the only difference between them is the signs here. So you see the signs are important. You know, sometimes we have positive here, so we have all positive in the first quadrant, but we have some negatives in the third quadrant, in the second quadrant, and then in the third quadrant we have some negatives and positives, but the values here are all same. So so everything is related to indeed 45, and the quadrant is changing the negatives and positives. Now, another way of, you know, determining the trigonometric value of an angle is to use the unit circle. Now, in the unit circle, we have this, okay. The unit circle means we have a radius of 1. Okay. Now, assume this is 1. Radius is 1. So it means here it's 1. So if you take this one here, it will be 1. Okay, for now, let's not put here cosine theta and sine theta. Let's take a point here, xy, and let's say this is x and this is y. Okay. Now, because I'm not sure if you can see these, it says cosine theta, sine theta, and here's cosine theta, so I don't want them. For now, I will not have them. Okay. Then I will show you now how I will get the cosine theta and sine theta. So it's here theta for sure. Okay. Now what is this? What's the relation between x and y here? So this is y here, this is x, and we know it's the radius will be 1, which means the distance here from here to here, so it will be 1. So it means the hypotenuse of this, so the hypotenuse is 1. So hypotenuse 1 means this is x, this is y, so x squared plus y squared should be equal to 1. And you know this is the circle equation, the unit circle equation. When you take the square root of both sides, then you will get 1. For sure, the x squared plus y, the square root of x squared plus y squared is equal to 1 if xy is on the unit circle. So now, this is clear now. And then I want to write the formula for cosine theta. cosine theta is the adjacent side divided by the hypotenuse, which is x over square root of x squared y squared, and x here divided by this. What is this? This is just the radius, which is 1. So I end up getting with cosine theta is indeed the x value. And I can write the same thing for sine theta, which will give us y over 1. And now I end up with getting sine theta is equal to 1. So we have some surprise here. The surprise is whenever you take a point on the real line, on the unit circle, so like here theta, and when you draw this one, you automatically get these xy's as cosine theta and sine theta. So it's saying this. So what does this mean? This means by a good protractor, we are able to find the angles, the trigonometric values of different angles. Now, let's show it. Now, in some books, you can see this type of figure. In this figure, you can find the different values of the cosine and sine values of each angle here. Now, for example, here 1, 0. Okay, let's start with the 0 degree. So the initial side and the terminal side, they coincide. So you got like this. So if it is 0 here, so they have to be same, right? So you don't have this, so you have the same thing. The terminal side and the initial side coincide. Now, take this point. This is 1, 0. So you can say here cosine 0 is 1, right? And here this is sine 0 degree is 0. So this point is telling us directly cosine 0 is 1 and sine 0 is 0. Now you can pick other points here. After some calculation, you can get this is cosine theta, cosine 45 degrees is square root 2 over 2, and sine 45 degrees square root 2 over 2. And okay, and some students ask me, okay, is it like this or is it 1 over square root 2? Indeed, they are same. So you can get this one by, when you rationalize the denominator by multiplying both with square root 2, we'll end up with square root 2 over 2 because of here. So they're same. So in some books, sometimes you will write it this way or sometimes you will write it this way. It's okay. It's both okay. Now, by using this unit circle property, what is cosine 90? Can you? Okay, you can stop the video and try to do it by yourself. Cosine 90 and sine 90. Here, this is 90 degrees is this one. This is the terminal side, and this is 0, 1. So 0, 1, 0 will be cosine 90, and 1 will be sine 90. And how about cosine 180 degrees and sine 180 degrees? So you can directly say it's here, this one is -1 and this one is 0. Right, the first one is always correspond to cosine. This is 180 degrees. The second one is always sine. Now, how about finding sine 270 degrees and cosine 270 degrees? So you find here the 270 is here, and then you look at here, so it will be 0, -1. Sine is -1 and 0 is this. Now you can use this directly, by using XY formula, or you can directly use this unit circle formula, unit circle property. And now, how about the others? Let's look at here. Cosine 360 And what about sine 360? You can come here. You can come to the same point here, same side. So again, this will be 1, 0. So you got 1, 0. The terminal side will come to the x-axis again, the positive x-axis again. So this is 360. So the trigonometric value of cosine, the trigonometric cosine and sine of 360 is 1, 0. Now use the figure to find the angles whose terminal sides pass through the following points on the circle. Again, you can use this one in here. Okay, where is 0 minus 1? 0 minus 1 is here, so this has to be corresponding to 270 degrees. Where is minus 1, 0? Minus 1, 0 is here, so it will correspond to 180 degrees. Now minus 1 over 2 minus square root 3 over 2 will come to 210 degrees. And square root 2 over square root 2, square root 2 over square root 2 over 2, and square root 2 over 2. It corresponds to this one here, and this point is on the terminal side of 45 degrees, so it will be 45 degrees. Okay, we'll come to that later. Find the angles whose triangle passes through the following points on the unit circle. Okay, this minus 1 over square root 2 and 1 over square root 2. Okay, it's obviously telling us this is cosine of something and this is sine of something. And then let's find this 1 over square root 2 is where. This is on the second quadrant. Minus 1 over square root 2. And this 1 over square root 2. And it will be here. They're same. So if you draw this figure in the triangle, so you will end up with 45 degrees. So what's the angle here? It will be 135 degrees. So this corresponds to 135 degrees. And how about this one? 1, 0, where is it? It's 1, 0. It's the x-axis 1 and y-axis 0. So it's just the initial side and the terminal side is same. So what angle is it? We don't have any angle, just theta is equal to 0 here because the terminal side and the initial side are same. So it will be 0 degrees, or you can say it's 360 degrees. And 1 over 2 minus square root 3 over 2. Okay, 1 over 2 is here. Minus square root 2 over 3. Where is it? It's here. Now we have to look at, this is the terminal side. It has to be 300 something for sure. Okay, let's look at here. It's 1 or 2. Let's look at here. Now this triangle, this angle here has to be what? Let's look at this triangle. We have this 1 over 2 here, and this is square root 3. And then when you calculate here the hypotenuse, let's say h. So since it's unit circle, the unit circle has to be 1. So because it's given in the question, or you can calculate it's just 1. Now this ratio here, this adjacent side divided by the hypotenuse is what? 1 over 2. Which angle is it? It's, if you remember, this has to be 60 degrees. This is corresponding cosine 60 degrees. So it has to be 60. So this angle has to be, you need 300. Like here in this try and check, you can see the figure. You can see the figure we gave before the unit circle. We will have this type of questions later. We will use another method to solve this type of problems. Now let's let's use the terminal side and the unit circle to find the values of trigonometric values of 90. We did that before, so you can take 1, 0 here, it's 90 degrees, so it will be, you can take 0, 1, and then use it in the formula here for cosine, for sine, you know, the xy formulas for tangent, for cosecant, and for cotangent, you know, all of them with the x and y formulas. This is x and this is y, and we know cosine is x over squared, x squared plus y squared, and sine is also x squared over sine theta is y over x squared plus y squared. Okay, find the trigonometric values of alpha whose terminal side passes through -3, 0. Okay, the angle is not important because it gives us, it says this is alpha. It doesn't matter. This is 180 degrees, but it's okay. So then use the trigonometric values. Cosine theta is x over squared of x squared plus y squared. And the sine theta is y over square root of x squared plus y squared. And the tangent theta is y over x. Now, if you don't remember them, like you can use it. Again, I'm telling you this. You can use this one here, x, y, which is x is here, y is here. Assume, I mean, you can, to get the values and to get the formulas, you can assume theta is in the first quadrant and find the formulas here. But when applying, I mean, finding the actual value of cosine theta, you have to stick to the original point in the term on the terminal line, which is -3, 0. So x is this, and y is this. So x minus 3, put them here. So you got cosine. Okay, it says alpha. Sorry, alpha. Cosine alpha will be equal to x over -3 over square root -3 squared plus 0 squared. So which is -3 over 3, which is 1, minus 1. And then you can do the rest, like sine alpha is equal to y, which is 0 over square root of -3 squared plus 1, which is 0. And tangent alpha, you can say it's 0 over -3 because it's y over x, you know. So you can get 0, and you can do the rest here because secant alpha, you know, it's 1 over cosine alpha, which is square root of x squared plus y squared over x. And you can do the rest. Take the reciprocals of the others, so you will find them. So by using the same method, you can find the values of cosine, sine, and the other values of 90 degrees, 180 degrees, and 270. So we call them quadrantal angles. So the 90 degrees and its multiples, they are called quadrantal angles. And here we have 0, 90, 180, and 270. And we can pick some value here, or I mean, a point here, or a point here, or a point here. And then we can find all the trigonometric values of them. Some of them, as you will see, they're undefined, and some of them are 0, some of them are 1, some of them are -1. So as you see, so it's hard to, okay, it's hard to memorize this. So for this reason, we are teaching you how to use these points when getting the trigonometric value. Since you will not use a calculator for it, you have to know how to get it from here. Okay, another way of finding the trigonometric values of the angles that are more than 90 degrees, or the angles that are not acute angles, is to use the reference angle. Now the reference angle is, okay, an acute angle all the time, and we will talk about the reference angle of an angle. So let theta be an angle in standard position. Here are the 4 cases. You might have this, or this, or this, or you might have this one, you know, in 4 different quadrants. It might be in 4 different quadrants. Now the reference angle of theta, okay, I will take the first quadrant first, is the acute angle that is formed by the terminal side of the angle theta, terminal side. Okay, this one. And the x-axis. So with the x-axis, you do such angle. So this will be an acute angle. So you cannot take this one. So you will take this one. And now the reference angle of theta here will be equal to itself. Now, is it true all the time, like it's equal to itself? No, let's try to do it here. Theta, look at theta here. So assume theta is this. Now theta is in the standard position, it's okay. The reference angle of theta is the acute angle, okay, acute less than 90 degrees, that is formed by the terminal side of the angle theta. So what is the terminal side of the angle theta? This is the terminal side. This is terminal side. This, you know, the blue one here is the terminal side, formed by the terminal side of theta and the x-axis. So x-axis is here. But it has to be, okay, this one or this one. It has to be acute, less than 90. So this becomes the reference angle of theta. So what is it? So it's equal to, its measure is equal to 180 minus theta. So how about, you know, having theta in the third quadrant? So if this is the case, if theta is here, so what's the terminal side? The terminal side of theta is this, the x-axis is this, and now the acute angle formed by the x-axis and the terminal side of theta is here, so it will be, this one will be reference angle of theta. So this is like theta minus 180. So then we might have the same thing also in the fourth quadrant. So let's have this in the fourth quadrant here. Theta is in the fourth quadrant. So now the terminal side here of theta. So terminal side is this. The x-axis here. So what are the 2 angles that can be, it can be done? It can be formed with the x-axis and the terminal side, this one and this one. But which one is the, okay, we cannot take this one. But which one is acute? So this part is acute now. So this is your theta, this is our theta. And now this becomes the reference angle of theta. Now let's find the reference angle of the following angles here. 30 degrees. Okay, 30 degrees is the initial side, terminal side, 30 degrees. Now what is the reference angle? The terminal side and the x-axis and the acute angle. So the reference angle is always acute. Acute means less than 90. So what is the reference angle? Ref angle of 30 degrees is again 30 degrees. Now 2 pi over 3, what is the reference angle of 2 pi over 3? Now it's better we change it to degrees. This is in radians. So if it's not saying degree, it means it's in radians. So it's 180 degrees. Pi means 180 degrees. So 120 degrees indeed is asked. So what is 180 degrees? Sorry, 120 degrees. So 120 degrees is here. Okay, what is the terminal side? This is the terminal side of 120 degrees. This is the x-axis. Now, what is the angle formed, the acute angle formed by the x-axis and the terminal side of 120? So it will be this acute angle. What is this acute angle? It's 60. So if you change it to, again, in radians, so it will be pi over 3, right? So the reference angle will be 60 degrees, or pi over 3 radians is the reference angle of 2 pi over 3 radians. Okay, let's do it for 250. 150 is 190, 180. This is 270 here, so it has to be something like this. So because this is 270 here, so it will not reach 270. Okay, this is the terminal side here of this is the terminal side of 250. Terminal side of 250, sorry. And then the x-axis is this one here. But we are interested in the small angle here. This is the acute angle. So this is the reference angle of 250, which is, how can you get it? It's 250 minus 180 degrees, which is 70 degrees. And in the same way, you can do the others, like, okay, let's look at here. This is 4 pi over 3, and this is like 4 times 180 divided by 3. This is 240 degrees. It's almost same calculation, so you can tell this one is 60 degrees. So the reference angle is alpha here, reference angle 60 here. It was 70 degrees. Reference angle. You can do the same thing. I mean, I don't want to draw it for 10 degree difference. Now, but here, let's come to 300. So 300 is a little more than 270, right? It has to be like this. So this is the terminal side of 300. So this one here. And the x-axis is here. So as you see, the x-axis terminal side. The acute angle is this one. So this should be the reference angle of this one here, this angle. This is the reference angle of 300 degrees. So what is this? Its measure is, of course, the full rotation is 360 minus this part here, which is 300. So it will be 60 degrees. So you see this alpha is 60 degrees, the reference angle. Okay, now here you will see the solutions here of all. Now it's drawn here. They're all drawn here. Okay, it's a little hard to see, but anyway, you can see them. Okay, we go one by one. Okay, instead of using, the degrees, you can use directly pi for 180 degrees, or you can do this job in, degrees and convert them to radians. It's okay. Now, we got some observation here. If it's here, it has to be same. The reference angle has to be same as the angle itself. And here, if it is theta here, then this part should be alpha, which is 180 minus theta. And if theta is in the third quadrant, it's theta here, so this has to be here. This has to be our reference angle, which is theta minus 180. And if theta is here, then it has to be this angle, which is 360 minus theta. So it's basically, this rule is telling you what to do if you have, if you want to find the reference angle of the theta in different quadrants. So you can use the definition of the reference angle, or if you don't, if you don't do well in this, like using the definition here, this terminal side and this definition here, you can directly go ahead and memorize the rule here. You can memorize the rule if you want. And we have the same thing for, okay, for the angles whose measures are given in terms of radian. These are in terms of radian. So this rules are rewritten in radian. So the basic thing is like pi is 180 degrees, and pi over 2 is 90 degrees. 3 pi over 2 is 270 degrees. So it's the same thing, except in terms of degrees, we use the radians, and theta is an angle between, it's given in radians, okay? Theta here is in radians, because these are given in pi, 2 pi, these are radian measures. Now, by using these, you can apply the formulas here. 60, okay, it's in the first quadrant, it's just 60. So 2 pi over 5, which is like 2 times pi over 680 divided by 5, this is 72 degrees in the first quadrant. So the reference angle will be same. Okay, in quadrant 1, it's same itself. In the second quadrant, it will be 180 minus 60, which is 20. So we use this. Or you can also make this one to 160 is here. So this has to be the reference angle, which is this one. And here, 7 pi over 6. You can, okay, look at, okay, where is it? It's, you can do it like 7 times 180 is like divided by 6 is 210. So where is this? 210. 210 is like a little more than 180. So 210 is here. So we have this angle here. This reference angle has to be 210 minus 180, which is 30 degrees. And what is 30 degrees? If you change it to radian, it will be pi over 6. So as you see, it will be pi over 6. Now, if you can see all the 180 degrees and 90 degrees in terms of radians, it's easy to see this. And one other thing is 330, it's here. What's the reference angle? As you see, the reference angle will be 360 minus 330, which is equal to 30 degrees. So it will be 30 degrees, as you see here. Now you can use the rules here if you like. Now we can directly give these 100 is in the second quadrant. So 100, so the reference angle has to be this one here, 80. I will just say 80, alpha is 180. So if you do this one, okay, one way to see is like you can say here, this is 0, this is pi over 2, this is pi. And what is this? This is pi, 5 pi over 4 is equal to pi plus 5 pi over 4. So it has to be a little more than this. So it will be pi over 4. So the reference angle. But if you want to use just the degree, it's okay. So you can say it's 5 pi over 4 is equal to like 5 times 180 degrees divided by 4. So you can use this one, and it will be 225 degrees. So 225 degrees is this one here. 225 degrees is 180. So this acute angle with the x-axis will be 225 minus 180, so it will be 45 degrees, and it in radians will be pi over 4. So again, the reference angle will be pi over 4. It's pi over 4. And 280, it's somewhere like here because this is 270. And what is the reference angle? The reference angle is this one now, and it's 360 minus 280, which is 80 degrees. Alpha is 80 degrees. And you can do this one 7 times pi over 3, 7 times 180 divided by 3, which makes 7 times 460, 7 times, it will be 420 degrees. So this here, 420 degrees is more than 360, so it will come 360 up to here, and it will come back to again, it's 420 degrees. So it will, so what is this this triangle here? Sorry, this is the acute angle, the angle with the x-axis and the terminal side, it's again how many degrees? 60 degrees. So the reference angle here will be 60 degrees. In radian, it will be pi over 3. Okay, if you don't have the formula for an angle, you can directly say, hey, it's the acute angle between the terminal side and the x-axis. So 200 is where it has to be something like this, 200. So what is this angle? It will be 200 minus 180. So this angle will be 20 degrees. So the reference angle is 20 degrees. Okay, we reached the main point in the slides. The main information you will get here is that the main point is what is it? Okay, the relation between the trigonometric value of an angle and its reference angle. So basically in the, okay, if theta is the angle and alpha is its reference angle, then we have these relations. So depending on the quadrant of the angle, the trigonometric values of the angle theta and its reference angle are same, almost same, except the sign. So what is deciding the signs here? It's here they're same, and here it's minus. They're almost same. The absolute values are same, but here it's minus, there's minus, and here this is minus, and there's tangent theta is equal to tangent alpha in here. So the only difference is that for some functions we have sine theta equal to sine alpha, for example. The trigonometric values are same, and some trigonometric values are same except the sign here. It might be minus or plus. So how can we do it? So it's, if we look at these quadrants here, it will be easy for us here. In the first quadrant, we can say all the cosine, sine, and tangent are all positive. So you say all positive. And here only sine positive. So all, say, as students. And here only tangent is positive, so I will say all student thinks, okay, tangent thinks. So in the fourth quadrant it's cosine, so you can say all students thinks calculus. All students think calculus. So this is think. So calculus is one of the core math courses. Everyone in engineering has to take this one. Almost all areas are taking calculus, no matter what science or engineering track. You have to take this calculus. So for this reason, they say this: all students think calculus. So it means all of them in the first quadrant are positive, and only sine is positive in the second quadrant. In the third quadrant, only tangent is positive, and in the fourth quadrant, it's only the cosine is positive. So this is telling us the relation between the reference angle and theta. So whether they're same or they're same except the sign. Now we can use this in finding the trigonometric values. First, determine in which quadrant the following angles lie, then write cosine, sine, tangent of each angle in terms of its reference angle. So this is in the in quadrant 1, no, quadrant 2, and its reference angle is, okay, what is it? It's 100. It has to be 80 here, right? If it is 100, its acute angle is 100. It's 80. Its reference angle is 80. So then, what is cosine 100? So all students sine, tangent, and cosine. So only sine is positive, so cosine will be negative. So we say here cosine is negative, so it will be cosine 80 degrees. Now when it comes to sine 100 will be equal to positive because of the sign here, s, positive. And how about the tangent? Tangent 100 degrees is equal to minus, because I don't see tangent here. All STC. All STC. Okay, now, okay, this is Saudi Telecom. Okay, all STC. Okay, this is better. So tangent 180. So tangent 100 will be minus here in the second quadrant, so it will be minus tangent 80 degrees. So in the same way, we will find the reference angles and the quadrants, and we will try to set up the relation, and we will decide, or we will determine the sign of and the trigonometric values. Okay. Now how about this? Okay, I will try to do it like this: 2 times pi, or 3 means 2 times 180 divided by 3. That will be 120, so 120 is here. So this is the 60. So all STC. Okay, what does this mean? Cosine will be negative, so it will be cosine 120 is minus cosine 60, and sine 120 is sine 60 because it's positive here. And the tangent 120 is minus tangent tangent 60. Okay, in the same way, we can do the rest. Okay, you can stop the video and try to do it by yourself. And now, if you have radian, please change it to degree and think about it. Do as it is, like degree. Then you can change it to radian if you want. So here, for 2 pi over 3, it's the in the second quadrant. You can convert this one so it will be 120 degrees. So you can do the job with the 120 degrees, and then it will be 60 degrees, the reference angle, and then you can write the values here by using all STC. And 200 is the same way. You can use 20, and the third quadrant is tangent is positive, all STC. Cosine and sine are negative, so you can set up this relation between 200 and 20, its reference angle. Only tangent is positive in the third quadrant, and you can do the same thing. The reference for this one will be equal to pi over 3, and then you can set up these relations here. It's in the fourth quadrant, so only cosine is positive. They're equal, but here for the others it will be negative. Okay, let's look at these. It says determine which quadrant is it. It's the first quadrant, and here it's the second quadrant. You can calculate this one as 135 degrees. Okay, please check it. And this is in the third quadrant. You can check it, and it will be 11 times 180 divided by 6. So it will be 330 degrees, so it will be in the fourth quadrant. Okay, we have this now, all STC. So all positive, S positive, sine positive, tangent positive, and cosine positive. So we are talking about all positive. Here, these are the positive trigonometric values. And the reference angle here is the same as itself. So cosine 45, like in the first one, since the reference angle is the same as its, the reference angle is same as the angle itself, so no need to write the equalities here. Okay, I will skip this part because I will write the same thing as cosine sine 45. And here, what's the reference angle? The reference angle, if you calculate, you will see it's 45 degrees. So cosine 3 pi over 4 is equal to, here its sine is only positive, so it will be negative sine pi over 4, and its cosine will be equal to cosine pi over 4, and then tangent will be negative. Tangent 3 pi over 4 is equal to minus. Okay guys, sorry, I'm tired, so it's now in the middle of night. I'm trying to finish this. Okay, you can do the rest here, and you can find the try and check the answers of the try and check exercises. Okay, let me write here cosine. Here cosine 260 is all STC. STC. Okay, this is here, so it will be 80 degrees, and this will be cosine, but it will be minus. So it will be minus because tangent is positive only. So sine here 260 is minus sine 80, and tangent here is the only positive trigonometric value because of this. And you can do the same thing for the last one. This will be 330 here, right? No, this one is 330, sorry. So then this will be 30 degrees. So the reference angle is 30, and it's in the fourth quadrant. So reference angle is 30 degrees, and you can write here, okay, all as C. Okay, this cosine is positive and the rest is negative, so it will be cosine 30 degrees is equal to this cosine 30 degrees, and the sine 330 is equal to minus sine 30, and tangent 330 is equal to okay, there's no only cosine positive, so it's only cosine positive here. And then we will have this minus sine 30 degrees. So minus tangent 30 degrees. Okay, can we find the values of them? Yes, they should be in our memory. Remember 30-60 triangle, it's 1, square root 3, 2. Use these values. Okay, let's look at these questions and let's solve them. Find the quadrant where the terminal side of the angle theta lies if cosine theta is bigger than 0 and sine theta is less than 0. So this is a question that is, asking which quadrant is theta in. Okay, where should be theta? So just look at it. Cosine theta, cosine is positive, sine is negative. So where is this? Here it's all, it cannot be all positive. Here its sine is positive only, it cannot be here. Here tangent is positive only, and here we have cosine positive. So sine is also negative here, so it has to be this. So it will be in the fourth quadrant. Now let's do the other question. So the fourth quadrant, so let's make it clear. This is for in Roman letters or Roman symbols, it's in Roman numerals, it will be 4. So tangent theta, if the terminal, find tangent theta, if the terminal side of theta, angle theta lies on the second quadrant and sine theta is 1 over square root 5. Okay, theta is the angle lies on the second quadrant, so the theta has to be something like this. Okay, now sine theta is 1 over square root 5. Okay guys, there are some shortcuts for this question, but I will not do it with the shortcut. Okay, first I will do it with the usual way. The usual way is, so you say this is the reference angle alpha. So then we have sine theta is equal to sine alpha because of the all STC. And then sine alpha turns out to be 1 over square root 5. Then you can set up the triangle like this, alpha 1 square root 5 مقابل and then here you find x by using Pythagorean. X is equal to 2. You end up here 2. Now what is tangent alpha? From here 1 over 2. Okay, now we come back to theta. What is tangent theta in here? It's minus tangent theta. Sorry, minus tangent alpha. So the relation between the reference angle and its the angle itself is minus here, and then you say minus 1 over 2. So you can say it's minus 1 over 2. So we start with theta. We went to Sine alpha, its reference angle, and we set up the triangle, and we find the tangent alpha, then we get back to tangent theta. Like most students are doing some other way. I mean, this is the way we do it. And some students are directly making the triangle, and then they make this 1 squared 5, 2, and then they directly say it's 1 over 2. But be careful here, you have to pay attention to here. So some of the students, they stop here. So this is not the solution. The solution is tangent theta. So you have to pay attention to what is tangent here. Tangent is negative or positive. So you have to pay attention to the quadrant of theta. Some students are doing it like only this one here. They skip the alpha. They just come to here, do this, and directly say tangent theta is 1 over 2, not minus 1 over 2. No, you have to pay attention to the quadrant at the end, because the quadrant is telling us the tangent is negative or positive. Okay, so let's see how it is done here. Okay, I used X here. It says B. Okay, this is another one. Let's do it. Cosine theta, if tangent theta is 1 over 2 and sine theta is less than 0. Tangent theta is this, and sine theta is less than 0. So here, these two are telling us the quadrant here. So tangent theta is positive here, right? 1 over 2. Sine theta is negative. So, okay, where is, which quadrant is it? Okay, which quadrant? So here, all STC, it cannot be all, because all positive here, so this is, tangent is positive. We want only tangent positive, all S, sine positive, no. Tangent positive, cosine positive, and here sine is negative, but tangent here is negative also, so this cannot be the part, so it will be in the third quadrant. So first we say theta is in third quadrant. Okay, then, okay, we can start doing this. Okay, third quadrant, we have this. Let's say this is alpha, this is our theta. Alpha is this one here, the small one, alpha. Okay, now tangent alpha, tangent theta is equal to tangent alpha here, right? Because it's positive here, so they're same. So this all STC 10 is positive here. So theta is equal to tangent alpha. Tangent alpha is then what? 1 over 2. Then set up the equation, set up the right triangle. Alpha, 1, 2, and here by Pythagorean theorem, 1 squared plus 2 squared, squared 5. Now, what is tangent alpha? Sorry, what is asked? Oh, sorry, cosine theta is asked. So you got back to cosine alpha, which is 2 over square root 5. Now you go back to cosine theta. Cosine theta is here in the third quadrant. Cosine theta is negative. So you say it has to be negative 2 over square root 5. So this is the answer. So briefly, if you want to give steps here, step 1, find the quadrant of theta. Step 2, okay, set up the right triangle using reference angle alpha. And then step 3, from the right triangle, find the trigonometric value asked, which is asked. Step 4, put negative or positive depending on the quadrant. So here we said theta is in quadrant 3. So we set up the right triangle with alpha here. Alpha is tangent, alpha is 1/2. So then we find square root 5. Then we find, so what is asked? Cosine theta. It's 2/square root 5 by using alpha. So this is cosine alpha. And then cosine theta is just negative or positive of this value. So this is in quadrant 3. In quadrant 3, cosine is all STC, so it's negative, so you say it's negative 2/square root 5. Because it's in quadrant 3, cosine should be negative, so we get back to negative 2/3, negative 2/square root 5. Okay, let's see how it is done here. So our way is, the proper way is to start with theta, find the quadrant and find its quadrant, and then set up its relation between its relation to reference angle, and then set up the triangle for the reference angle, and then find the corresponding, find the trigonometric value for the reference angle, and then by depending on the quadrant, put plus or negative for the for theta. Okay, now let's look at these problems here. A, find the quadrant where terminal side of theta lies if tangent theta is bigger than 0 and sine theta is less than 0. All positive, sine positive, tangent positive, and cosine positive. So here sine is negative, it's not this, and the tangent here is positive, but the tangent is negative here, so we cannot take it. So tangent is positive only here, and sine is negative. So we say this is the third quadrant. Okay, let's come to B. Find tangent theta. If the terminal side of theta lies on quadrant 4, okay, theta is in quadrant 4, and sine theta is minus 1/square root 5. So if you say alpha is the reference angle, so let this be the reference angle of theta. Then we have this then, right? Sine theta is equal to minus sine alpha. And sine alpha automatically becomes 1/square root 5. Alpha is always positive. this is the acute angle. So you set up the triangle then. 1 square root 5. What is x? X squared plus 1 squared equal to 5. So you end up with x equal to 2. So then you write here 2. Then what is asked? Tangent. Tangent alpha is that. So tangent alpha, you find it. It will be 1 over 2. Then you have to go back to tangent theta. What is tangent theta? It's in the fourth quadrant. Tangent theta is negative. So you have to put negative here. Tangent alpha, this one. So be careful about this. Be careful about this part here, because most students are coming to here, then forgetting this one. So in most students, they come up here and they write here theta, and this is not true. Theta, you have to pay attention to the negative value here. So the answer will be minus 1 or 2. Now, let's look at here the secant theta. Find secant theta if tangent theta is equal to minus 1 over 2 and sine theta is bigger than 0. So how can we do this? First, let's start with tangent theta. Okay, let's start with the quadrant. So tangent theta is minus 1 over 2 and sine is positive. So we have to find the quadrant where tangent is negative, so it cannot be this. Sine is positive and tangent negative. So obviously sine is here bigger than 0, positive, tangent negative. So it has to be the second quadrant. So tangent positive here, we don't want this. And as sine is negative here, so we don't want this part. So it has to be second quadrant. So you say, because of these two conditions, theta is in quadrant 2. Okay, and then you can set up this here, theta here, and then alpha here. So alpha is the reference angle of theta. And here, tangent theta is given. So tangent theta is minus 1 over 2. So it means tangent alpha is directly 1 over 2. So you never take the minus here. So here you see minus, but here is always plus. So alpha, it makes always plus. So you don't take minus. So the next thing here is, so this was an important point. So then the next thing you have to do is set up the equation. Set up the triangle with alpha. Alpha is the acute angle here. So it's 1 over 2. So x will be square root 5 for sure. You can use the Pythagorean. Then what is wanted? Secant. Okay, we don't have a formula. Do we have a formula for secant? This is 1 over cosine theta, right? So now we need cosine theta indeed. So we need cosine alpha. But it's cosine alpha here. This is adjacent side divided by the hypotenuse 2 over square root 5. So cosine theta is now what? Cosine theta is all STC. S is positive, so cosine will be here negative, right? So I say cosine theta is now minus cosine alpha, which is minus 2 over square root 5. So what is secant theta now? It will be minus square root 5 over 2. Okay, guys, it's a little, this one, I mixed up everything here. So please replay the video and take it a little back and try to follow my steps here. I was tired, so I just wanted to stop this one, and I tried to hurry, so I messed it up this way. Please rewind it. Okay, please play it back and then rewind it back, then play it again, play forward. Then you will see, I mean, you will understand what's going on here. So please, this part is important, especially this type of problems are important.